Hello everyone. Now we are going to discuss about construction and working principle of isolators. Isolators are non-reciprocal passive microwave devices which avoids the reflected signals. An isolator is a two-port non-reciprocal microwave device which provides minimum attenuation in forward direction and maximum attenuation in reverse direction. It is used in chain of RF networks between source and load in order to avoid the reflected signals from the load towards the source. Thereby, it increases the stability of the network. If you are not using an isolator between source and load means the reflected signals from the load may reach the source, thereby the stability of the source gets affected. As we discussed earlier, isolator is a two-port network, so it will be having the scattering matrix of dimension 2 cross 2. So the element S21 alone having value 1, all other elements are 0. Construction wise, the Faraday rotation isolator consists of two resistive cords, namely input resistive cord and output resistive cord, and it consists of ferrite rod between input resistive cord and output resistive cord. The property of resistive cord is to provide the minimum attenuation when the plane of wave is 90 degree with respect to the plane of resistive cord, and it will provide the maximum attenuation when the plane of microwave signal is parallel to the resistive cord. When the signal enters through the input signal, it is made 90 degree with respect to the input resistive cord and it will travel without any attenuation. Whenever the wave passes through the ferrite rod, it undergoes 45 degree phase shift. Already, the output resistive cord is 45 degree displaced with respect to the input resistive cord. So now the input wave will be having 90 degree phase with respect to the output resistive cord. So the wave will travel to the load without any attenuation. When some part of the wave is reflected by the output port, that wave will be having again the reflected signal will be having 90 degree phase with respect to the output resistive cord, and whenever the same wave passes through the ferrite rod, it undergoes 45 degree phase along the clockwise direction. Now this wave will become the reflected wave will become parallel to the input resistive cord. So the as per the property of resistive cord is the wave will be completely absorbed by the input resistive cord. So thereby the reflected signal will be stopped in the input resistive cord itself. Thereby the reflected signals are avoided reaching of input port. Isolators are mainly used in RF circuit design, and also it is used in measurement of microwave parameters, and also it is used in chain of RF networks in order to avoid the reflected signal reaching of the microwave source. A microwave circulator is a multi-port passive microwave device which will allow the signal to flow from nth port to n plus 1th port in only one direction, and it will not allow the signal to flow in opposite direction. Although there is no restriction for number of ports, the most commonly used circulators are having only 4 ports. For example, if we consider 3-port circulator means whenever the signal is fed at port 1, that signal output we can get it from port 2 only, and there is no output at port 3. So port 1 and 3 are isolated ports. This figure shows the schematic diagram of 4-port circulator. 4-port circulator can be constructed by joining two rectangular wavegates in parallel. These two wavegates will be having a common wall. There will be two slots will be available in the common wall through which only a coupling takes place from primary wavegate to secondary wavegate to primary wavegate. The thickness of the wall is made to provide 90-degree phase whenever the signal crosses from primary waveguide to secondary waveguide, similarly secondary waveguide to primary waveguide, and also it will be each waveguide will be having one phase shifter which provides different amount of phase shift in forward direction as well as in the reverse direction. The phase shifter which is placed in the primary waveguide provides the 180-degree phase shift in the forward direction and a 90-degree phase shift in the reverse direction. Similarly, the phase shifter which is placed in the secondary waveguide provides 0-degree phase shift in the forward direction and 90-degree phase shift in the reverse direction. For example, now whenever we transmit a signal from port 1, the signal is supposed to reach only port 2, and there should not be any output at port 3 and 4. So now you consider the example, whenever we feed a signal at port 1, that signal reaches the port 2 in two different ways. That means one is it travels through only the main waveguide, and second signal is it travels from main waveguide to secondary waveguide, and it travels in the secondary waveguide itself, and through the second pole it crosses from secondary waveguide to primary waveguide. There are two signals will be available at port 2. Each signal will be having 180-degree phase shift. So both the signals are added together. So we will get at the output at the port 2. Similarly, you come to port 4. There will be two signals available at the port 4. The phase of one signal is 90-degree. Then phase of another signal is 270-degree. So both the signals are having out of phase. So both the signals are get cancelled. So there will not be any output at port 4. In this way only the circulator provides the signal allowed to flow in only forward direction, and it will stop the signal in the reverse direction. As we discussed, the most commonly used circulator is having 4 port. So the scattering matrix will be having the dimension of 4 cross 4. So in those only 4 elements will be having value 1, all other elements are 0. Let us say S14 is 1 and S21 is 1 and S32 is 1 and S43 is 1. Remaining all other values are 0. The characteristics of circulators are insertion loss less than 1 dB, and isolation in reverse direction is from 30 to 40 dB, and VSWR is less than 1.5. And some of the applications of circulators are circulator can be used as an isolator, and also circulators are used in duplexer applications. The duplexer is used to merge two signals into one channel. The circulator is used in the duplexer in radar to route the signals from the transmitter to the antenna and from the antenna to the receiver, thereby avoiding the signal to directly pass from transmitter to the receiver.